Okay, so we're on video number 4, which is the servo motor. We're going to be learning how to use that with our Arduino. If you're interested in my other videos, I've so far covered how to connect an LED, a potentiometer, and a button. So the couple of things we're going to need for this is an Arduino UNO, as always, a servo motor, or a micro servo. I'm using a 9-gram micro servo, a Servo Blade. This is just the bag that came with mine. You only need one. 3 male-to-male jumper cables, and again, as always, an Arduino UNO USB cable. Okay, so just taking a quick look at the Arduino UNO, you'll see that we're going to be using 3 pins. The ground pin, the 5-volt pin, and the 9 pin, which is, I'm going to show you that here again. It's easier to read if I show you on this angle. There's the ground pin, which is labeled GND, the 5-volt pin, which is labeled 5-volt, but is also then labeled AV, and the 9 pin. It's also a PWM pin, which you'll notice by having the tilde at the front of the number, just like the 10 and the 11, that little squiggly line. And this right here is a 9-gram micro servo. And you'll see here that it's just labeled with that sticker in the front, and it has 3 cables coming out of it: brown, red, and orange. The brown is the ground pin, red is the power pin, and the orange is what we call the data pin. Typically, I label my ground wires as black, but in this case, it's brown, so we're just going to think brown is black. And so there's 3 pins. And so what I'm going to show you next is how to connect this servo to the Arduino UNO using those 3 pins I showed you in the previous clip. So let's get our breadboard wires, and remember these are 3 male-to-male breadboard wires. So you can put the pin in the port matching. So again, ground in this case is black, which is in ground. Oh, sorry, I'm using black as the ground wire, and they have it as brown. So black to brown, red to red, which is in the middle. So we're just gonna stick that right there in the middle. Yep. Make sure it's a good connection. There we go. And orange to orange. And I selected these colors so that they would match to be easier for those watching, if you're new to this, for you to follow. And so now essentially we have an extension of that initial wire with 3 colors: black, red, and orange. And so like I said, black is ground. So we're going to find the ground pin on the Arduino UNO, and we're going to connect it. Right, just like that. And then we're going to use the red to connect to 5-volt power. So right there, and we're going to connect it. And again, make sure your connections are solid so they don't pop out. And the 9 is the data pin, which we're going to connect to the 9 port. And so 8 and 9 right there. Right there. Sometimes these holes are really hard to find, so it's good if you just kind of run the pin along the one you're trying to find, and make sure you're making the right connection. It's very easy to make the wrong one. We're gonna throw on a blade for the servo, just so that when it's moving, it's more visible. You can connect your servo to all types of things, but they kind of give you these like little plastic blades to get started. So we're gonna connect that there. It also comes with screws to connect that better, but because this is just kind of a demo and I don't want to make a more permanent connection, we're not going to worry about the screw. Perfect. And so that's our servo connected to our Arduino UNO. And so now you're asking, now what? What do we do now? Arduino program. And usually when you start a new program, you essentially get two stubs here: setup and loop. They might have a comment in them. They typically do. You can delete the comment or you can leave it if you want. It's up to you. But essentially this is what you get when you start. And so how do we go from this to something that works with the servo that we connected? And the first thing we need to do is what we call including a library. And so we're going to leave a comment here that says include servo library. And the reason I'm leaving this comment is because I'm actually just going to make all of this code available on GitHub for anyone that wants to play around with it. The link will be in the description below. And so how do you connect a servo library? And it's simple. You just would include servo.h. And that will that's everything you need to connect your servo library. And so some of you might be asking, what is this? What is a library? Why is it important? Why are we using it? And to give a simple explanation, a library is a file that contains code that was typically and usually written by another person. You can write your own libraries, but in the case of using a library, we're using code that was written by another person. This is useful because you can use libraries instead of rewriting the wheel, or in this case, rewriting code, every time you want to perform very similar and common actions. And so in our case, in using our servo, someone else has already done the hard work of writing common functions that you will need to interact with a servo and packaged it into a library that we can now use. I will link in the description below a more complete look at the servo library for those who are interested. There's a lot more to learn about how to interact and connect with servos and kind of what they can do and more things that you can take a look at. Or if you just want to see what the code looks like, you can do that as well. So the link will be in the description below. So now that we've included the servo library, what's next? How do we connect? That's great, but how do we connect it to the Arduino that we have at home? And so in our setup, we want to connect. Oh no, before we actually get to setup, I'm jumping ahead a bit actually. We need to create a new servo object. So we're going to say create a servo object. And again, I'm just including these comments so that later, if you come back to them, you can kind of understand and follow what was happening. And so how do we create a servo object? So using the library, we're going to write servo. And what we write next is the name of the object. So it doesn't matter what we put. We can have my servo. We can put custom servo. It doesn't even have to have servo. We can call it tree if we wanted to. Lowercase, we can call it tree. But to keep things easy and simple to understand, we're just going to call it servo. So this is a servo object with the name servo. And then we want to connect it. So how do we do that? So in setup, we are going to connect servo. And we want to do that by writing servo, which is the servo object we created, which we named servo. And we're going to use the attach function in the servo library. So this is code that was already written by someone else, which means all we have to do is use it. And that's going to say attach, and we're going to connect it to the pin that we attached onto the Arduino. And if you remember, we connected it to pin 9. Don't forget the semicolon at the end. So we've connected our servo. The next thing we want to do is we want to move the servo to what is called the 0th position. And that's because when we connected this servo, it might have been used before, somebody might have moved it or tampered with it, so it might not be at the position we want it to be at. And depending on what we're going to use our servo for, it's always nice that you know where the servo is at the beginning before you even write any code, so that if you're moving it to particular positions or by a particular amount, that it's kind of where you expect it to be. And so it's also going to give us a chance to use the write function, which is very important. So we're going to move the servo, or we're going to say we're going to center or reset the servo position to 0. Now, there's two ways we could do this. We could really just write servo.write and put the number 0, and that will do the same thing. But I kind of have a plan for what we want to do once the servo is connected and up and running. So we're not going to write 0 here. What we're going to do is we're going to set a variable to control the servos or hold the servo's position. And that way we can manipulate that position in the loop function below. So we're going to have a variable to hold the servo's position, and that should be like that. And there you go. So we're going to say int, and we could call this anything, but to keep this simple and easy to follow later, it's always good if your variables have easy to understand names. We're going to call it position. A better name that would tell you exactly what it is servo position. It's it's really long. It's long. It's a long name. So in the case of like simple programs that you're kind of writing for yourself, it's very common for somebody to write like POS or POS for position. But because again, I know people are learning and things might not be that straightforward, I'm going to give it a long name and call it servo position. So our servo object and our servo position, which we're going to set to 0. And again, don't forget the semicolons. Okay. And so we've reset the servo position to 0. So this function setup only happens once when the program is run. So essentially, the very first time the program is run, we're going to attach the servo to position 9, and we're going to write it to the 0th position. And so now in our loop, and what is the loop? The loop is essentially the code that you want that is going to be running continuously from the point that the servo is connected and the file and this code file is uploaded. It will run in infinity. Essentially, as long as the Arduino has power, this is what's going to run over and over and over and over again. And so we're going to do something very fun, something very simple. So our servo only has a movement radius of 180 degrees. So if you've done a bit of trigonometry, you'll know that a circle is 300. A full complete circle is 360 degrees. So 180 degrees means this servo has a half moon range of motion. So it can go kind of like from one end to the next end. So think of like a horizon line, and it can go from one end to the next end on the same horizon line. And I'll put up a graphic to make that very simple to understand visually, because that might have been a bit hard to follow for some. And so what we're going to do is we're going to increment the servo position every, let's say, 10 points till it gets to 180 degrees. And then when it gets to 180 degrees, we're going to go back to the 0th position. Okay, so that's a bit hard to follow, but we're going to code it up and then I'll show you on the servo what that looks like. So the first thing we need to do is check, let me not forget my comments, check the position of the servo. And so this is going to be important because, again, the servo only has 180 degrees of motion. So if we set it to a number higher than 180, it won't work. So we're going to say, so the first thing we want to do is check. So if servo position, servo position is equal to 180 degrees. So basically, if we've gotten to 180 degrees, we want to set the servo position back to 0. Else, so if it's not at 180 degrees, we want the position to be equal to position plus 10. Now, we're moving it plus 10 steps every time because I kind of want the servo to move a little bit faster for display purposes. We could move it one position every time. It'll take a little bit longer. Now, it's also important that whatever number we choose here, that it will get to 180 degrees. So because we're basically checking if it's equal to 180 degrees and setting it to 0. And if the position is equal, and otherwise once it hits 180 degrees, we're setting it back to 0. So if we chose something like something not divisible by 180, we wouldn't get there. Or if our servo position was set to 1 and we were incrementing it by 10 every time, then we'd go from 1 to 11 to 12, and we'd kind of be out of sync and may not get to 180. So I've already done some simple math here to make sure that this is possible. So if you're getting any weirdness in your code and you didn't use these numbers, it's likely that there's something going wrong here in terms of you're either not getting to 180, you're kind of going under or over, and the servo's kind of freaking out because it doesn't know what to do next, or it can't do what you're asking it to do. Another thing you can do is basically say if it is greater than 180 or less than 180. So there is options that you can do here, but for simplicity's sake, we're going to do it this way because I've already tested it and it works. Okay, so that's great. We've set the position of the servo based on what its current position is. Oh, and I've already made a mistake here. This should say servo position. So if you caught that, give yourselves a thumbs up. Servo position. So servo position equals 0. Servo position equals servo position plus 10. Okay, but how's that going to move the servo? It's not. So we're going to move the servo to the new position that was determined based on this kind if block here, if else block here. And so we're going to say servo dot write, and we're just going to write it to servo position. And we can finally change this 0 to also be servo position, right? There we go. So we basically have no hard-coded values for moving the servo. That's all happening. It's only happening once here, and then dynamically it's being set here based on this if-else block. There's also one other thing we need to do, time delay. And this can be whatever you want it to be, but I've already tested this, and I like the speed of 500. And that's basically saying half a second. So every half second, we're going to do this loop. We're going to wait, and then we're going to do the loop over and over again. Okay, and so that's everything we need. One thing I like to do is to verify my code to make sure things are as expected, and I didn't get any errors, so that looks good. And so the next thing we need to do is connect our Arduino. So I'm going to connect that back to my computer. And if we go into edit, or not edit, if we go into tools and then port, we have COM3 Arduino UNO on communication channel 3. And so we're going to upload. Okay, so we're starting this shot before I had actually connected the Arduino. So if you connect your Arduino and then hit upload, it will take a couple seconds, but then eventually the code will start running. And so here we see the demo of what we just built. Every half second, it's moving 10 degrees. Yep. And then when it gets to 180, which we'll do here in a second, it goes all the way back to 0, and then it just continues to do that. And so that's what I meant when I said the loop will just run continuously. There's nothing to stop the loop, or there's no other interactions, and so this will just keep going and going and going in this manner until the Arduino loses power. Okay, so using some of the skills we learned in one of my last videos regarding buttons, I went ahead and just kind of wired this up as well to continue playing around and exploring. And so basically each button sets the servo to a particular position. The far right sends it to 0, the middle sends it to 90, and the far left sets it to 180. And so these are some of the interesting things you can do if you continue learning Arduino and the platform and the different kind of sensors and modules you can connect. You can get really complicated and really fun projects. So I just encourage everyone to continue exploring, and look out for the next video where I'll pick another, again, module and learn more about it.